Well, hello. So we are live. Uh, Thanks all for making up to the first live virtual MuleSoft meetup. Yeah, I know. This is excited. I'm so much excited because this is the first time we are having this. It's been a long time this was due. And to begin with, the intention is our goal with this whole virtual meetup is to break any physical location barriers and make sure all everything that we can get to you is accessible to you. Give me one second. Sorry. Yeah. So that is the intent, and so let's begin with it. So for the first session, since I'm organizing it, and I thought, okay, it's a good time to have a first session with my own content. So the first session is all about using Dockers, which is a container technology, to use that inside the MUnit. Let's start with it. Let me share my screen. So one quick thing is we do have an YouTube chat somewhere on either this side or this side of the screen. I don't have access to it now, but I am gonna get to it once the presentation is done. So I will suggest you to ask your questions or anything. Keep asking questions there, and at the end we will go through it, and I will try to answer as many questions I can. If I cannot get to every question, I'm sure I'll be able to like send you guys an offline thing, something, and try to answer as many as I can. So let's begin with the session. Well, so I believe you guys should be able to see my screen now. Let's So MUnit Dockers and test containers. Testing database flows with the confidence. Give me one second. Yeah. The agenda for today's session will be first, we'll just quickly introduce ourselves to unit testing and a first principle. I will tell you what that principle is. Then a quick introduction to MUnit testing framework and features that it gives us. Then we will see what mocking is inside the test and whether we should do that or we should not do that. In-memory H2 database, we will see what is the problem with using H2 database, and not really the H2 database itself, but using that within our MUnit test cases based on other scenarios. Then the question is, what is Docker and test containers? We will come to that. It's interesting part, so we will see what it is, and we will see how we can use Dockers and test containers inside our MUnit test cases to to get some better testing where database is involved. Then at the end we will try to see what are the all the benefits of using those containers in MUnit, and then we'll get to the question and answer. Hopefully I'll have like enough time for it. So unit testing, it's a development process where we try to test a smallest possible unit in our application code. In general, in any programming, if it is related to mostly Java, you can say the smallest units could be classes, methods, functions, or any other smallest segment of code that you can test in an isolation to an rest of the code. Why to test? I'm sure there are like lots of benefits of it. I tried to put few benefits here. Definitely it will improve the application code quality. Then importantly, it helps you to find bugs early in the development because you have test scenarios, you have the expected output and everything. So you will catch bugs early in the development phase. Change process is simplified. How? Because If you are changing any part of your code and when you have a test case, you know that if your test case is broken, that means your existing code is broken. So it's easy for you to make a change and be confident about it. Okay, I know I haven't broken anything since all my test cases are succeeding. It helps you to improve your debug process, because when you write a test case, you will have some assertions, and when test fails, looking at that assertion, you should be able to tell, okay, where exactly the problem is. And there are many more. So let's see. This is the first principle, first rules. This I included it here so that it makes sense for you guys what we are doing. So first rules are defined or described in the book Clean Code by Uncle Bob Martin or Robert C. Martin. It's a nice book. If you haven't read, I would suggest just take a look at it. So what it says is first. First is F is for fast. So your test cases should be fast enough so that you don't end up like disabling test cases when you are doing development. You will do that if test cases are taking longer time. They should be independent, meaning like there should not be any dependency between the test cases. That is like also called as isolated tests. Repeatable, irrespective of which environment you are running your test, they should always give you the same result. Self-validating. So at the end of your test case, you should always assert your output or assert what you expect out of it. It should make sure whether test pass or fail. Timely. This is not really the attribute of test, but at what time you should write your test cases. Definitely not after the product code is moved to the production. You should try to write them somewhere during the logical phase of development, where you are still either working on the code or before you start developing your code. So these are the rules you can try to follow during test cases. So now let's come to the part where what is MUnit. MUnit is a Mule application testing framework that allows you to test integrations and APIs built using and for the Mule runtime. This is definitely something a very specific testing framework built by MuleSoft and very specific to Mule technology. So you can write an integration tests as well as unit test cases with it. On the first slide, we saw different unit components like classes, functions. In Mule applications, we can relate them to flows, subflows, custom components, custom transformers, etc. Uh, I wouldn't say like try to test the standard components, because believe me, Mule has already put a lot of efforts to testing all standard components. So anything where you do customization, you write flows, you write logic, those parts should be tested. MUnit is pretty much good tied integrated with Maven and Surefire to give you to provide you test automation. You can easily integrate that with your Jenkins build or any other CI/CD tools where you can automate all your testing. To make the testing development fast, it is fully integrated with Anypoint Studio. So it's easy for you to just when you are in Studio, just right click and use some context menus and generate your test cases. So we will see that when we go to the demo part of it. Some features that I tried to put in here, definitely there are more features about MUnit, but the main features I tried to capture here. Mocking capability, you can mock the different components during your testing. Spying, it allows you to spy your components to make sure and verify what is the payload during the test when that particular component is getting called, so on like that. Assertions, it does have its own assertions, like you can see in here. The in the spy there is an assert equals, which will verify, okay, something is equal to something. For integration test tool suite, it does provide you some tools such as database server, which we are going to see in next slides, and FTP servers. These are like a kind of a dummy small servers that will run during your unit test cases. Maven and Surefire support, we already saw it, like it's fully integrated with Maven. Test coverage, when you run MUnit test cases, it does generate a nice report for you, wherein it will show you how many components you have covered, how many different processors are executed during your test case. So that will help you to identify how much coverage you have during your testing, and definitely more on there. So this is a sample flow, sample subflow get user testing, where it's setting a payload and it's going to write that to an outbound. So this is an example of MUnit test case where we have a test case. You can see I have highlighted few things there. Mock when, where we are mocking and file outbound endpoint, and instead of really writing the file, what is going to do is when your test case executes and it reaches to that particular file outbound endpoint, it is going to return the same payload whichever is there during your flow, instead of really calling the file outbound endpoint to write your file. Same thing for mock spy, where you are spying it. Then assert equal, that is the one I was mentioning earlier, where you have an nice built-in assertions, where you can specify what values you are expecting at that point. MUnit set is another part where you can set your dummy test payloads to verify during your testing. So this is a sample of MUnit test case. So moving forward, mocking process. The reason I put mocking here separately is all our demos and all that is gonna be around mocking part of it. What mocking process is? It is the R part in the first principle, R repeatable. Mocking is what those are the objects, components. There are objects and components in your flows which are dependent on the external systems, or they are not part of the flow that you are concentrated on. So in such cases, these mocks helps you to mock the behavior of those components. That way your tests are repeatable. So if you have a dependency on an external system, that system will not always be available for you during the test. So that is where you will put a mock and say, okay, when this particular system gets called, just mock it and return some dummy payload to me, which is again all a well maintained and controlled environment. So in terms of Mule, you can like mock endpoints, subflows, or connectors or anything. Here I have shown an example where it's mocking a file outbound endpoint, and when it gets called, it is going to return the same payload to the caller. Now the question is, should you always mock components? Let's see. Because mocking components is fine. Definitely you don't want to have like 10 components in your test case, and your test will not be really a unit where you are interacting with so many systems, and external systems can go down anytime. So you need to decide based on what systems are involved and what flows, subflows are involved, whether you should mock or not mock. So it depends on your use case. Specifically for this one, since we are going to talk about the database thing, flows with database connector. So we have for this demo, when we get to the demo, I'll show you an API, library API, which allows you to get the list of books from a library database, also post a new book to the collection. For this particular slide, we have a post API method which accepts a JSON file, and then it has a database connector there, which is gonna insert that new book into a database. On the right side, you can see it has an insert query which inserts into book and gets some parameters from your payload like title, description, price, total quantity, and available quantity from there. So whether we should mock it or we should not mock the database connector, it's a good question. What can go wrong with SQL? In my opinion, database connectors are little different than other connectors. Why? Because in database connector, we are going to have SQL queries. They can be simple SQL queries, as simple as like select star from books. Okay, that's fine. But sometimes you might have like a SQL query which is joining 4 or 5 different tables with some conditions on it, where conditions and all those things. So what can go wrong with all those things? Sometimes you can accidentally edit and which results in invalid or malformed syntax at runtime, meaning like I can by mistake insert a semicolon or something which you won't know unless that application or that flow particularly runs at runtime. Then incorrect position or count of values in insert or values parameter. For example, I can miss to add now the last parameter in there, which is available quantity, or which inserts the create date time. So I can miss that, and I wouldn't know that until I really run that flow. There can be typos, or the actual production system can be different than your test system, which means whatever the syntax that you are using in test may not be supported into the production. So if I mock the database here, and when database connector is called, if I say, okay, when db insert is called, instead of calling the real database, just return me some dummy payload. If I do that, then probably I won't find any of these issues unless my application is live and running, which I don't think is a good idea. So that is the reason for database connector. In my opinion, I don't think we should mock those. So what are the options? Oh, small thing. Choose wisely. I will say don't mock it. Okay. So what are the options? In-memory database server. The the MUnit framework that we have, it does provide us a database server, the one that we touched in the earlier slides. So what this database server is, this server is an kind of wrapper over H2 database, which is an in-memory Java-based database. It is lightweight and fast. Of course, it's in memory, and it's just one jar. But at the end, it is different than your in production database. So this is, you are not gonna have H2 database as your production database. So there are differences between H2 and other databases such as MySQL and MS SQL. Some of the differences, like I can mention, is the way you write store procedures in H2 database are not real SQL store procedures. They are Java functions that you write in H2. But if you have a MySQL as a backend database, you might have store procedures and any other SQL objects. So now those are not supported in H2. So what you will do with all that? So when we write an application, definitely the flows that we are testing those because they are gonna go live into production. Same is the case is when you have a database script, SQL script, you want to test. If you are not moving the same script to the production, then I doubt the validity of testing it, because if you are not moving the same component that is tested thoroughly to the production, then what you are moving to the production is not really a tested code. So these are the things that in-memory database has problems with. So let's see how we can overcome with all these problems with the solution given by Docker or test containers in there. What is Docker containers? I'm sure all of you have heard about it. Docker containers, they are like so many they are very popular now. Docker containers. Containers are standalone executable package of piece of software that includes everything required to run in it. These are these will help you to isolate your software from surrounding environment, thus providing your controlled environments, which means you can have an containerized instance of a MySQL database, and without really installing that on your system, you can just run that as a Docker container. Now the MySQL instance that is running inside your Docker container is separated from your host machine, which means anything happening to host is not going to corrupt your database in there. They are lightweight, they are standard, and they are secure packages. So for example, the command at the bottom that you see, docker run, name MySQL, port 3306, a dummy username, password. When you run this command, even if you don't have a MySQL already installed, but provided you have a Docker installed, what it's gonna do is it is gonna get a latest image of MySQL database, run that image in your local server, and MySQL will be ready and available for you to use. When we get to the demo, I will show you quickly how what happens when you run this command, because the database that we are using for our API is inside in this container. The most interesting part, test containers. This is one of my favorite library for testing. What it is, test containers is a Java library that supports JUnit tests, providing lightweight, throwaway instances of common databases, Selenium, web browsers, or anything else that can run in a Docker container. It's very interesting. So what happens is, like, when you run a test case, you don't want any manual intervention, like, okay, let me download this image, let me start the container so that it's available and all that. So what this test containers will allow you to do is start and throw away instance, which means the instance will be started only for your testing, which so that it's isolated from your environment. It exists as long as your test case runs, or as long as you want, and after that it's gonna be killed and thrown away. You can use test containers for integration test, unit test, acceptance test, and anything that you can need for basically testing. So for example, for MySQL, there is a containerized instance of it which you can run and use. The other important part about it is customized JDBC driver to easily integrate into our applications, because when we use database connector in our Mule applications, we are going to define an JDBC URL to be configured for our database connector. So with test containers, the only difference that you see in the connection string is TC, which comes after JDBC. So as soon as you put that, and if you have all the test containers library on your class path, it is gonna properly start your test containers drivers and then start your containers. We will see that during our demo. Test containers, a quick thing about it is it does have some prerequisites. So since it's a Docker based solution, you must have Docker installed on your machine, or if you are on Mac OS, Docker machine is required on it. It needs JDK 1.8 minimum. It is compatible with JUnit. So how does test looks like when you are using test container? In a standard JUnit test case for test containers, this is not a MUnit test case, this is not a Mule related test case, but it does show you how test containers can help you to write a test. So in the test, you can see it is starting a MySQL container, an instance of a MySQL database. So it will do a MySQL.start, which will start your container, and then it's gonna do a query on it, MySQL select one, get the result, and at the end, in the finally block, do a MySQL stop. So what happened here is, before your test start, it started a MySQL instance, ran a query, verified the result, and stopped the container. You that all that happened on the real MySQL instance, not on any of the like H2 or any other in-memory database. But what about the MUnit test case? Like, that was all the plain Java thing. So here comes something, introducing MUnit DB test containers connector. This is a new connector. This connector is give me 1 second. So this container is a community return. It's not like an official by MuleSoft. I created this connector. So what this connector allows you to do is, 1 second. And I think I missed a slide. Okay. So what this connector does is, it's a wrapper on top of test containers, which is customized to be used in your MUnit. So in MUnit, similar to database server provided by MUnit, It allows you to start a test container instance for your testing, stop the test container instance. It also allows you to run the initialization script, because when you're starting your database, you would want to have database at some specific condition, like create these tables, run this store procedure, have this data inserted before I run my test case. So this connector is gonna help you do all that. It is available on Maven repository. The Studio plugin is also there, so you can just go to Maven repository and install the Studio plugin on there. So now, using this test containers connector, let's see how the MUnit test case looks like when we use the real database instead of the database connector. So let me switch to the Studio here. Okay. I hope you guys can still see my screen. So we have these API. Let me show you guys an API if it is running. So this is the part. I already have a MySQL container running here. So MySQL is started, and if I run, so while it starts, okay, it started. So these are the API application that we have, where we have an post and get for the books, and then we have one get for the with a book ID, where we will try to retrieve the book for it. One more thing we have here is a report. Let's say for the demo purpose, we have a flow which calls a database store procedure, calculate library value, and it gives us what is the worth of all the books that we have in our database. For the simplicity, the procedure is so simple, it just sums it up. But this is, yeah, it's gonna open. So this is the SQL I have. Create a table and a store procedure. So what you see on the right side is integration test tools, where DB server, this is the database server that is integrated inside MUnit, and it uses the M2 database. Now when you install the test containers connector, you are gonna have a new test tool here, DB test containers, which similar to what we will do with the DB server. We will have an test connection suite. Before our test case start, we are going to put a DB test containers here. What we can do with it? Definitely, first we are gonna have a test connector for it. For connector, you can define its connection parameters here, JDBC URL and everything in for that. What we have, so these are the parameters we have. DB URL. If you notice here, we have JDBC:TC. That is what is gonna trigger the test containers when we run our test case. All these parts not really matters, because when test container starts, it's just gonna use the localhost and the dynamic port that is created by Docker. Since we are not, one quick thing here is, when you just say MySQL here, it is always gonna get the latest version of the MySQL, and sometime you may not be using the latest version. So it is possible to specify what version of MySQL you want during your testing. Like in this example here, tc:/MySQL:558, JDBC host name and all that. So if you specify a version here, when test container starts, it's gonna pull that particular instance of the MySQL database and run that for you. So let's go back in here. So what we have before shoot, we have a test containers here, and what we are gonna do is on test containers you have 4 operations available, like start container, stop container, run init script, and run SQL script. Start container, as its name says, it will start the container, and stop container, it will stop it. Init script is the part where we will specify, okay, when my container start, run this library.sql file before anything else happens, so that when my test runs, my books table is already created, my procedure is already created, and anything else that I need, it's already created in there. So let's go back in here. You can see I have everything configured. Same way for the after thing, you will stop the container. One thing to note here is definitely creating a database and everything is time consuming process. So if you have a very big lengthy SQL with lot of tables and objects, that itself can take some time. So you have like two options in here. One, when you are starting your suite, create your database at that point itself, which means you can select this like run init if configured. So on the test here, db init script where we are, sorry, yeah, on the db init script where we are specifying the db init script path from here, like a library.sql, you can either run that as a part of your suite startup itself, meaning like just run it one time, or run that before the test, which means before every test your whole database will be dropped and recreated. So you can use the run init script task and use that during the before test instead of before shoot. So you can choose between that. Now we have before and after shoots there. Now when we run the test, our test container should start and give us a MySQL database instance that we will need for all our testings. Like when I'm gonna hit the get library books method on it, it should go to the database and get all the data from the books table. Since the table is empty, before you actually call your API, you can insert, like here I'm gonna insert two books records in here and then run the test on it. So let's see, let's run all our tests and see what happens. Oops, don't save anything here. Let me stop the server. That is expected. I'll tell you why it failed, but here you can see something is happening. So you can see the test containers got invoked. It is connecting to the local Docker installation. It is checking all the prerequisites are done, like Docker is properly configured and everything. Okay, we just pass the screw. Yeah, yeah. So what it did is before suit, since we have started the test containers, what it did, it connected to the Docker, and then it tried to verify whether the Docker is properly configured or not. It was properly configured. Let me just scroll down. Oh, here. Sorry. So you can see it is creating a container image for MySQL colon latest, which since we haven't specified the version for it, it is pulling the latest version of the MySQL. If you specify the version, it will pull up that given version for it. Then it created a Docker container for it. It started a container, and now it's waiting for this verification query it at this particular URL. So we have this, it obtained a container connection and your database is up and running. Whole MySQL latest version is running and your before test run. So in before test, in this particular example, instead of creating the database at suite level, I created that at the before test. So this guy here, right? And here, this guy before test db container, I said okay, create my database. So what it is doing, it is gonna read my library underscore db.sql and run that in the database that it just created. Once that is done, then it will start running all your tests in there. We are not mocking the database, we are actually hitting the MySQL database and getting all your data as well as the store procedures and everything. So you can see everything succeeded in here. Every time in the before test, it did create a library.sql, it did run that SQL, created our database, and at the end, everything finished successfully. One thing failed here, which is a test suite for H2 database. So here we are using a DB server, not the database test containers. This is a DB server using the H2. The reason it failed is, if you see here, so it complained about this. The INODB default Latin 1, it's not expected because this is a this particular script that we gave to the test cases is MySQL specific, not to the H2. So to make it run on the H2, I will have to remove this part from the library.sql and then I can run. Now that is the part I was mentioning. There are some differences between the H2 and the MySQL. So if I remove this is not a very critical part, but you can imagine the other parts where it's critical for your production version and you have to remove it or modify the script for your testing purpose, then you cannot really rely on the same script when you are moving it to the production. And that is the reason this M2 particular test case failed to start the database instance. So this thing where we have a store procedure, it did call our store. So here what we are doing is we started the test container before we actually call our flow, which is going to call store procedures on the database and get us the value. We don't have any data in the database table. So what we can do is, apart from this library db.sql, I have a different sorry I have a different SQL here, a small SQL, which deletes everything from the books table and inserts two records in the script table. Now this is my controlled data for testing. So what it will happen, I'm gonna use the test containers connector here, and I am going to use run SQL operation on it and specify, okay, run the books underscore insert dot SQL query before you invoke my target flow for it. So it will run that query, insert everything. Now you can imagine you can like delete as many tables as you want and condition your database which suits for this particular flow. And at the end, then you can verify, okay, the output returned by store procedure matches or not. Since I inserted two records, I know the total library value or the value of total books I should have in my table should be 600, and that is what I'm going to verify it here. And payload dot size equal to 2, that's just because my store procedure is returning two data sets. One is that value and second is actually list of all the books. So that is how the difference between the H2 and MySQL can be overcome. Like if we have to, even if let's say to get this thing working, if I remove if I remove this part of it, it is again gonna the test is again gonna fail because h2 does not support this part. H2 does not support the store procedure, so it might again fail, saying okay, I don't recognize this particular object. Now as soon as you modify this, it's not exactly the same script that you will run to the production. But with test containers or with this particular thing, I can literally copy this library.db.sql and I can create my production database instance or the final database instance using the same SQL without any modification to it, which gives me a more confidence on it, saying okay, I already tested my whole all flows, all my application against this particular database SQL and all my flows. So I know if I move this to production, it should work the way I expect it to work. Uh, yeah, I think that's pretty much of it. Yeah. So quick summary of the test containers connector is the things that you can do with it here. It allows you to manage your containerized instance of databases. Now, what database instances are supported by test containers? As of now, you can definitely start a MySQL container out of it. You can start Oracle XC edition out of it. Postgres is supported. In future, there will be more databases like MS SQL or anything. But apart from that, you can really start anything that supports Docker containers. The test container connector that we have right now may not support you to start non JDBC specific containers. For example, if you want to start something using a Docker Compose or something, it may not be supported, but there is a plan to add more support to it so that you can start instance of any database that you want. So let's go back to the session here. Yeah, so that was how test containers works inside MUnit. What are the benefits? We already talked about it. Like, you are really using the same as production database. It's not really a mock database or any other database, so that definitely gives you benefits. What are those? You are testing against the same database as production. No incompatibilities, no differences between the test database and production. Script that you use during your test database can be used as is for your production. That gives you more comfort. And now, frankly, with all these things, aren't you like more confident about your code now because you have tested it well? I think that's all, folks. Thank you, and let's see if we have any questions now. So let's see on the thing. Okay, let me. Okay, so stop sharing here. Yeah. So, Jason, what is needed as a setup for installation Docker? Like I said on the one of the slide I showed, test containers. It definitely depends on the Docker. So yes, you will have to have Docker installed on your machine. Second, it needs a JDK 1.8, so that JDK should be there. I don't think anything apart from having a proper installation of Docker, like you can see, if you go to the Docker side, you should be able to just install um, Docker for your machine. If you are using a Mac, you should be able to install the Docker machine for it. If it is a not Mac, just install standard Docker Linux for it. David, have you used that approach with the use database? I can't imagine how much time it could spend to make MUnit tests in that way. I agree with you, David. That's why I said like everything takes time. So when your databases are huge, I'm sure you will have to find an approach which works. Like in the first principle, where F stands for fast, you should not have. If I have like a database where I have hundreds of table, like tens or 20 store procedures and like millions of data sets in there, it might slow you down. So that is where just creating the empty database objects and having only few records should get you going. But yes, based on the database side, you will have to do some tweaking around it, or choose to mock few connectors where it's really not needed or something like that. Tapping this question again. Gradle support for MUnit on roadmap. I cannot really answer that question. Gradle support for MUnit. I can relay that question to MuleSoft guys and see if they have any answer for it. But I cannot really officially say anything for it. Yeah, welcome, David. Thanks. So, any more questions? So this session will be recorded, and everybody is gonna get an recording link. You should get that either tonight or tomorrow. You should get a link how to access this video on thing. So that's all. Thank you very much. And before I close it down, a quick question is: can you explain a bit about using Spy? Spy is what you can do with Spy, as name suggests. You are going to spy on particular component. Like if I have, let's say, an logger component in my test case, it's in between my test case and before logger, I have a data v which is setting some JSON value or some Java component. Using Spy, what you can do is you can define, okay, when my that logger gets called, verify the payload before that particular call is XYZ, or payload after that particular component is XYZ. So not because if you use the standard assertions which only gets executed after your test case is finished, or sorry, not after the test case, after your flow is completely executed, that is when your normal assertions will work. But during the flow, if you want to make sure in between your flow execution, the payload or the conditions or the variables have this value that you really expect, that is when you will use Spy. So if you see back to the same slide in there, you will see it has a two parts Spy: before assertion, before and after assertion. So you can verify that. Yep. Welcome, guys. Hope that answers, Bala. So we still have like 10 minutes if anybody has any questions. Yep, welcome. Thanks. Yeah. So since we have a few more minutes, the last thing is this is the first session in this whole virtual muleys thing. If you guys have any feedback or anything, how the next event should be or how next format should be, please don't forget to send us a feedback. And thank you all for joining us today. Thank you. Yeah. So I'm just waiting since we have a few more minutes. If anybody has any questions, I can wait. If everybody is good to go, thank you. Thank you all. Bye bye.